All right, our last lesson, my friends, of the unit. So integration with inverse trig. So let's see if we remember these formulas. So the derivative of arc sine of u, remember that was u prime over the square root of 1 minus u squared. So what does that mean? That means if I integrate this, okay, remembering that u prime is like du, if I have du over square root of 1 minus u squared, I should get arc sine of u plus c. And remember that tangent was u prime over 1 plus u squared. So in the same way, if I integrate this, I should get this. Now you go, well, we also did arc cosine, but remember the derivative of arc cosine was just a negative of this guy. So really you could go, well, if I integrated, I could put a negative in and do it arc sine or arc cosine. So that's why I'm telling you when you integrate with the arc trig, you will always come down to either, for the purposes of our class, you will only do arc sine and arc tangent. Now in example 1, I want us to look because I have two problems written there. And I did it this way. I really have 3 problems. Okay, I have 1, 2, and 3. Now, in example 1, and they're all very, very, very similar. And this is such a good skill, and that's why I did the notes this way. When they're all mixed together, you've got to make a determination on which one is this? Is this a power rule problem? Is this a log problem? Is this an arc trig problem? Is this a long division problem? Is this a, I mean, like what am I going to be doing here? And that's what the difficult part is because I can't tell you every time that you see a fraction what to do. You have to make a determination of which one. So I'd like for you to stop the video and see if you can answer 2 of those 3 questions, because one of them you don't know how to do right now. So can you figure out which 2 you're able to answer and answer those? So stop the video and do that. Well, hopefully you came up with, yeah, I can do this first one, because if you said that one good choice if I see a fraction, and really the first thing I consider is I let my u be the entire denominator. And I look at du, and I look at the variables. Do the variables in my du match the variable that's in the numerator? And if it does, it's going to be a straight ln problem. So this one, you're like, okay, cool. I'm going to x dx is going to be du over 2. So I'll have the du there and the 1/2 here, because again, x dx, I solved for this x dx. So I got du over 2. And so then I'd have a 1 on top, or a du on top, however you want to say it. And then I have u on bottom. So I have 1/2 ln absolute value of u plus c. Since my u is 1 plus x squared, I would probably write that with parentheses, or they would type it with parentheses, and that problem is done. So you were able to solve that one. Cool, cool. Now, as you got to the second one, you know, that's the one you don't know how to do just yet. And I'll come back to that one. I'll come back to him. And if you're like, well, I got something, I'll show you the flaw in what you got. You also could do the third one, because the third one, if you looked at it as 1 plus x squared to the negative 1/2 x dx. Now, how did I know it's not going to be a log problem? Because people, if you let your u be the entire denominator with the square root, its derivative has way more than just x in it. So that's where it's not going to be a straight ln. But if I write it this way, the other choice of u is not the entire denominator. This one I see a power. So a good thing is to take u to be what's being raised to the power. So 1 plus x squared, it has a very similar look to this one up here. So I'm integrating u to the negative 1/2. Again, x dx is du over 2. And so if I integrate, I would have u to the 1/2 times 2, because dividing by 1/2, I have the 1/2 that's on the outside, which of course those cancel. And I would have, since they have a power of 1/2, usually they would just write as a square root, I would get that answer. Which leaves us this third one, which you're like, I bet this is the arc-trig one, and you are exactly right. Arc-trig is not usually something I go to first. It's when everything else fails, I think, could it possibly be an arc-trig? Because when you're looking at this at first, you might go, let's u be the entire denominator, right? I mean, that's probably what you would think. But notice when I do du, and I get that 2x dx, people, if you have a variable here that's not there, or you have more variables, then it's not going to be an ln problem. That's not going to be the correct u. So you're like, okay, that's not it. Well, so I'm kind of out of things to do. So I'm like, I don't know. Ask yourself, does this one resemble one of these two forms right here? And you go, well, yeah, it looks kind of like this one. Okay, that should be obvious. There's not a square root in it. So, okay, that kind of looks like that. So when it's that way, just trust me, I like to put parentheses around my u. So on this one, it seems like, okay, that just seems like a pointless step. But just trust me. I could write that way. So my u, I want you to see it. My u is x. This is why it's inverse trig, because think about it. Wouldn't du just be 1 dx? So what do I have here? 1 dx is du, or u prime, and 1 plus u squared. How does that integrate? Well, we already talked about that. We talked about how that integrated was right here. That goes to arctangent of u, and of course in this problem our u was x, so I get this. Okay, let's look at example 2. Is it a straight power rule? I'm hoping you can see why it's not. Because again, if it were like this one, and what you're raising to the power, it would have an x in it, which you do not have up top. So it can't be a power problem. It's not going to be an ln because, again, the derivative of this whole denominator is way more than 1. It has variables in it. So it's not that. So you're like, okay, it's not that, it's not that. Oh, let me think arc-trig. Well, which one does it look like? Well, the one with the square root. So let's make it where I emphasize the form. What would that be? If I wanted to rewrite that problem as something squared, what would that something be? Well, to not change the problem, that would have to be 4x, because that tells me what u is. So du is 4 dx. So let's do the substituting. So the substituting would simply be this. Of course, dx is du over 4. I'll put the du on top. I'll put the 1/4 on the outside to get him out of the way. Over the square root of 1 minus u squared. Okay, how does it integrate? It integrates to 1/4 arc sine of u plus c. Now sub back in 1/4 arcsine of 4x plus c. And there you go. Good, good, good. Now let's do an example where we have a definite integration. Okay, let's see where we have a definite integration. Well, because of an example we did on the front, hopefully the integration of this guy doesn't seem so hard because you go, wait a minute, that's just the same thing as 8 times the integral from -1 to 1 of 1 over 1 plus x squared dx. Didn't we integrate 1 over 1 plus x squared on the front side? So hopefully you're like, oh, that's a piece of cake. That's 8 times the arctangent of x from -1 to 1. Well, let's remember what that means. Obviously, I know this part. You're like, okay, that's arctangent of 1 minus arctangent of -1. Now, again, I'm going to be honest. Guys, in free response, you can actually leave it like that. They would give you credit for that. Now, in multiple choice, they're going to definitely clean that up. So if you, I wanted to do one that they, for multiple choice, remembering that, go back to, I think it's on, like in the very front of your binder. I want to say number 7, actually. You had some notes on this, is that when you're doing arcsine and arctangent, so when you integrate, you get one of those. Remember, you're always going to get answers between -pi/2 and pi/2. So quadrant 1, you don't miss, but in quadrant 4, you have to name them negatively. So if it was multiple choice and I had to get down to an answer that they typed, arctangent of 1 means give me the arc who has a tangent value of 1. Well, that's the pi/4s, so that's pi/4. However, when I do arctangent of -1, that's going to be down in quadrant 4, but I can't name him as 7 pi/4. I do -pi/4. So, of course, that's 8 times pi/2. And so, as far as a multiple choice, they would get down all the way to 4 pi. All right, let's look at example 4. You look at example 4 and you think, all right, I see a fraction, so maybe it's an ln. Can you see quickly that it is not an ln? Why? Because the derivative of this would be 2x minus 4. It has an x in it, which you do not have, so it can't be that. So you're like, I'm kind of out of things to do. Well, when you're out of things to do, you consider maybe it's an arctrig. You're like, it's not an arctrig. It doesn't look like one of those. Oh, but it does. If I do something which you love, which is called completing the square. Now, remember, friends, that I cannot change the problem. Look at what I did right here. Okay? Look at what I did. I rewrote that problem and put in blanks. If you take out the blanks, I have the exact same problem. Now, why did I put in those blanks? Because I'm trying to get it. Now, clearly, this is going to be an arctangent. I'm trying to get it to look like this, 1 plus u squared. I'm trying to get this in the denominator, 1 plus u squared, something squared. So I'm going to pick a value so that when I factor this trinomial, it factors into something squared. How do I pick that number? Remember, with completing square, you take half of this number, which is 2, square it, and put it here. But sweet friends, if I simplified right now, would this denominator equal this denominator? Well, no, because I just added 4. The only thing that's legal for me to add is 0. So if I add 4, then I have to take away 4 as well. Because now if I simplify that denominator, I'm back at my question. I can't change the question. So what happens? Well, here's the cool thing. Don't get confused. I'm going to add. I can add in any order. 5 plus negative 4 is 1. Plus, the whole reason that you picked this is so that if I ask an Algebra 2 student, hey, factor that for me, they could factor it and it would factor into something squared. That's why you picked that specific number. It would be x. This is the sign that comes down. And of course, the square root of 4 is 2. So I have that. That's really what the question is saying. Now, if I put it in that form, you would know exactly what to do. You'd go, oh, yeah, yeah. U is going to be x minus 2. du is just 1 dx. So what I have is du over 1 plus u squared. So that integrates to arctangent of u plus c. So my answer is arctangent of x minus 2 plus c. So once you get it to this point, it's simple, but it's realizing when you have this, oh, this is that weird one where I have to complete the square. It doesn't look like an arc trig, but it really is. Okay? Last thought. When you see a fraction and the degree of the numerator is greater than or equal to the degree of the denominator, then use long division to rewrite the quotient. Okay, well, as silly as this sounds, okay, I'm going to erase this and do something kind of silly. Not silly, but if I said do 5 goes into 27. I'm going to do a different number because I don't want it to be the same number. Let's do 32. That sounds good. You say, okay, 5 goes into 32. You go 6. You multiply those together and do 30. And then you subtract and get 2. Correct? Now, this 2 is the remainder, which is correct. So you could say 6 with a remainder of 2. But if I wanted to write it as a number, I could say that 32 over 5, because isn't that what I'm doing when I do that division? That 32 over 5 is equal to 6 plus the remainder over the divisor. Couldn't I write the answer that way? Okay, which of course is 6 2/5. Well, that's what I'm going to do. I'm just going to do it with variables. So when this question was here, I look at that and I go, okay, I see a fraction. But wait a minute. If it's an ln, let's be honest, the power of this x has to be 1 more than the power of this x, because think, it has to be the derivative on top, right? So when the powers are the same or the numerator is bigger, I think long division. Long division does not do the integration for me. It rewrites the question so that I can integrate. So I have to do x plus 3 going into 3x plus 4. Now what do we do? Well, what do I need to multiply x by to get 3x? So that would be a 3. So I would have 3x plus 9. Now remember, you are subtracting, okay? So if you want to put parentheses around that, something to help you remember, because a lot of times I get 13 there. It's not 13. I subtract, and I should get negative 5. Okay. This is the remainder, is it not? This is the remainder. So what I'm saying is, just like I rewrote 32 over 5 as 6 plus 2/5, I'm going to rewrite this thing and say, really what that question is asking me is to integrate 3 plus, I know I could write minus, but remainder over divisor, dx. That's what the long division does. It helps me rewrite the question into something that I could integrate. Remembering that as I go down the line, I'm doing individual integrals. Not that you have to write this, but it's sure, I just want to give you a visual. That's 3 dx. I'll go ahead and put the minus 5 on the outside times the integral of 1 over x plus 3 dx. And then it's an easy integrate because this would be 3x. Friends, your u is x plus 3. What's the derivative of x plus 3? Just 1. So you have du over u. So that's going to be minus 5 ln absolute value of x plus 3 plus c. And there's my answer. You try example 6. I gave you the rough one there, didn't I? So let's see. So stop the video and just try. I hope that you see that you have to do long division. Okay, again, long division should be, obvious in that you can, the top is bigger. Now sometimes there are long problems where the top is bigger where you can do u substitution. If you think back, I'm trying to think what day it was when we did u sub. There's a way to do u sub on some problems, but it usually leads you to that. With this one, you're like, okay, x squared plus 1. Oh my goodness, into this big old long thing here. Let's see if we can do it. Here we go. What do I need to multiply x by to give me x to the 4th? That would be x squared. Then you multiply. So x to the 4th, x squared times 1, I like to line up my things so I don't add the wrong things, would be x squared. Now remember that I'm subtracting, so I have to make sure that I subtract the x to the 4th cancel. But this guy is also here, 2x cubed, those cancel, and then what do? Well, remember how you bring down stuff? So you have minus 2x. What do I need to multiply x squared by to get negative 2x cubed? Well, that would be a negative 2x. So then I kind of do it again. I multiply negative 2x cubed minus 2x. That, everything cancels there, does it not? But remember, I'd bring this down, so I have a remainder of 2. Now people go, how do you know when you stop like putting stuff up here? When you get into negative, sometimes it's a constant. I mean, if you write a constant, you're done. But sometimes it's just the x. If you have to say, what would I need to multiply x squared by 2 to get 2? You'd have to divide by x squared. When you have to start dividing by, that's when you're done. What's left is the remainder. So what am I saying? I'm saying that the question, instead of writing the question as it's written, remember my answer would be x squared minus 2x plus remainder over divisor, dx. Well, do you see it? The first couple are not too bad. Could you do that one maybe pretty fast in your head? Don't let the 2 throw you. You can bring that out in front, and you're really integrating 1 over 1 plus x squared. We've integrated that a couple times. That's arctangent of x plus c, and there you go. Fun times. So that's it for integration. It's a tough unit because there's so many different options. So hopefully you've been practicing all along, gotten faster at these things and learning what to pick for your U. And that's cool. All right, so have a great day. See ya.